Hi everyone, welcome to you all. Myself Sushant Prasad. I am doing the internship in EMERTZE and I have done home automation IoT based project. So let's see what I have done in this project. First of all, I am showing the presentation highlights which are IoT based home automation solution, PiximLab simulator, Arduino Uno, Arduino IDE, Blink mobile app, sensors and actuators, launch virtual serial port driver, serial communication. Objectives of this internship was C and C plus language programming in the first week, and the second week garden light control project, the third week temperature control system, the fourth week water inlet and outlet control, and the fourth week user interfaces with Blink application. So little bit let us know about the components that I have used and the softwares that I have used in this project. First of all, about the Arduino Uno. It is a microcontroller based on ATmega 328P. It has 14 digital input output pins. Okay, so this is the Arduino Uno, and it works on it ATmega 328P microcontroller. See, I have done or listed all the required knowledge about this. So I am moving further about the software. Arduino IDE, the Arduino integrated development software, Arduino IDE. So it basically connects to the Arduino hardware to upload programs and communicate with them. In this we write the code and we will compile it. PiximLab, it is a simulator. PiximLab have integration with MPLab X Arduino IDE for programming the board microcontrollers. We are using this because we are not using any hardware in real. We are using all the components here are the virtual. Okay, so virtual serial port driver, this will act as a port as the name suggests, and this will use in the water tank control. In this we will set the first port Arduino Uno as COM1 and the second port as COM2 water tank. Okay, this is basically used for serial communication. Now the Blink IoT app. Blink IoT app is a platform for iOS or Android smartphone that is used to control Arduino Uno, Raspberry Pi and Node MCU via the internet. This application is used to create a graphical interface or human machine interface by compiling and providing the appropriate address on the available widgets. So our project model is like that. We are sending informations, or you can say signals, to the Blink cloud server. This will then send to the PiximLab through Ethernet shield, and then we are controlling the hardwares. Now this is the connection diagram. Arduino Uno, CLCD, temperature system, Ethernet shield, Blink cloud and serial tank and LDR and LED. How I have connected, I have shown A5, A4. These all are the analog pins and the digital pins of the Arduino Uno, and these RX and TX. These are the receiver and transmitter pins of the serial tank connected with the Arduino Uno using the virtual serial port. And on the blinkcloud.com, we have to go here on the blinkcloud.com and we have to create our profile. Then we have to create the virtual pins. Later I will show you how I have created. And these are the LED and LDR. And according to this diagram, I have done the project and connected the connections between the hardwares. So for using Blink app, first go to the blinkIoTcloud.com and create your account. Okay, then add new template, then new device, and add the device name. Okay, go to the template and then edit and select a data stream. Click on the new data stream and select virtual pins. You have to create virtual pins according to your need. Okay, so then after that go to the Blink mobile app and then click the template that you have created. Okay, and after that you have to go to the developer option and you have to create the some widgets using the correct virtual pins. Now I have created the gauge widgets, button widgets and terminal widgets having proper applications like gauge widget to display volume of the tank and temperature on the Blink app, button widget to control heater control, inlet valve, outlet valve, cooler control through Blink app, and terminal widget to display the notifications like temperature is more than 35 degrees Celsius, turning off the heater, water level is full and water inflow disabled. Now let's know about the LED. All the things here. So basically I am telling what is LED and what I have used here. An LED is a semiconductor device that emits light when an electric current flows through it. Okay, now let's go to the second component, LDR sensor, light dependent sensor. It is actually a photo resistor. Okay, LDR is a resistor whose resistance changes as the amount of light falling on it changes. Now LM35 sensor, it is temperature measuring device. CLCD, we have used LCD HD 44780 I2C, which is based on the I2C protocol, and it is most commonly used display ASCII characters. Okay, Ethernet shield. As we know, our Arduino is not IP capable, so for connecting with internet we have used it. Okay, and the name is Ethernet W5500. Okay, this will maintain a connection between Arduino Uno and Blink IoT application. Serial remote tank. The serial remote tank is a tank simulator controlled by a serial communication protocol. This way, in this we have used actuators like inlet valve and outlet valve sensors like high floater, low floater, and volume sensor to know the volume of the tank, high floater, low floater to know the real volume, what is the real time volume of the tank, and inlet valve and outlet valve. Okay, so temperature control system, it basically consists of a heating resistor, an LM35 temperature sensor, a cooler, and an infrared tachometer. Now our first objective is garden light control. So in this project, in this objective we have read the LDR sensor value, and based on this we vary the brightness of the LED. Actually we are using it in the street light or garden light. As the sunlight will be available, the street lights will be off, and in the night or evening the street light will be on automatically. So this will be done as per the LDR. So this is the interface, how we are interfacing the LED and LDR in PixSimLab. Temperature control system. In this project we are controlling the temperature of the environment, cooler and heater as per the environment temperature. Okay, and we are displaying it on the CLCD and the Blink IoT notification terminal. So this is the systematic diagram how I have connected these all things: Blink IoT app, Arduino Uno, CLCD, and temperature system. Okay, now this is the interface how I have done, and this is the PixSimLab, this is the CLCD, temperature control, and Ethernet shield. Okay, the third one project is water inlet and outlet valve control. In this we will using the serial communication. So for serial tank and the Arduino Uno. Okay, volume display we will do on the CLCD. Okay, and controlling the inlet valve and outlet valve using the button widgets on the Blink IoT app, and we will control the volume of water in the tank. This is the systematic diagram. Okay, Blink IoT app, Arduino Uno, CLCD, and water tank. Okay, serial communication, COM1 port on Arduino and COM2 port on serial tank, virtual serial port, using the virtual serial port. Okay, all hardware assembled in the PixSimLab. Finally the project will look like this. I will add a video in the last how I am controlling that. So you can see there are different written things on the CLCD, like inflow on, and here out flow is off. Okay, finally the Blink mobile app interface looks like that. Tab 1, tab 2 I have created. Okay, tab 1 for temperature control system, and tab 2 for water control system. Okay, finally it is done. Thank you so much. I am adding a video after that how I have controlled the hardwares through the Blink IoT app. So I have finally connected all the connections between the hardwares in the Pixing lab, and as I have showed, this is the Arduino Uno. I have set the environment of Pixing lab as per the Arduino Uno. This is the CLCD, this is the LED, this is the LDR, this is the temperature control system, and this is the Ethernet shield to make a connection between IoT Blink app and the Arduino Uno. Okay, and this is the serial remote tank, and we have connected the serial remote tank with the Arduino using the virtual port pair. See, this is the COM2, and here I am showing that this is the COM1. Okay, now I am opening the Blink IoT app from my phone, and I will show you how I have done all the things, and I am using the system. Let me open the Blink IoT app. See, as I opened the Blink IoT app, I got an home automation template. I will click it. I have created that template on the Blink cloud. Okay, see, there are two tab 1 and tab 2 in home automation. Okay, in the tab 1 I have set the how to control the temperature control system. So here is cooler button, heater button, and the temperature. Here I am showing how much the temperature is in current time. Or this is the notification panel. Here I will print all the notification. Okay, now let's come to the tab 2. Here it is inlet valve, outlet valve. Okay, and this is for the water control system. Okay, now see, on the LCD, first I am going to use the tab 1. Okay, okay, let's on the heater button. As I on the heater button, it is continuously, you can see the temperature is increasing. You can see both side, on the CLCD and on the temperature. Okay, on the Blink IoT app. Now one thing you see, temperature is above 35 degrees Celsius, turning off the heater. As the temperature is above the 35 degrees Celsius, the heater will automatically turn off. Okay, this is the how the coding works here. Okay, now I will open the cooler. So one thing there will happen, that the temperature will not decrease below the 27 degrees Celsius. It is developed by the Pixing lab, so this will not decrease below the 27 degrees Celsius. Okay, I am turning off the cooler. Now let's come to the tab 2. Now I will control the water system. So let's off the first outlet valve. See, as I off the outlet valve, there is a notification here that I have off. Now see, one thing, tank is full, turning off the inlet valve. So automatically when the inlet valve is on and the tank will be full, it will be automatically off. Now I am opening the outlet valve. See, water is continuously decreasing here. Okay, you can see. Now one thing will here. See, there is a notification. Volume of water in the tank is less than 2000 liters, so turning on the inlet valve. So as the water will decrease in the tank by 2000 liter, the inlet valve will automatically on. Okay, see the inlet valve and outlet valve both are open here, and you can see the temperature volume is constant, because at the same rate the water is going and coming in the tank. Okay, see, this is the final project, and you can see all the notifications are print here on the CLCD, as well as the notification panel in the Blink IoT app. Okay, so this is all about the project. And the last one, garden light control, I am controlling it using the LDR sensor. See, as I decreasing the resistance, the brightness is decreasing, or finally it is off. Means when there will be full sunlight, the LED will be automatically turned off. Now as I increasing the resistance, that means the evening and then night, the brightness is increasing. So this is all about the garden light. Now I have totally explained the project. This is all the project. So finally it is done. Thank you so much.